In electronic ignition systems, the contact breaker is eliminated and switching of the primary circuit is carried out electronically. Optical sensors inside the distributor can be used to sense the crank angle position, and an appropriate voltage signal is then sent to an engine management electronic control module. In this type, a signal rotor plate is attached to the distributor shaft. It has 360 slits at 1 degree intervals on its outer edge. Inboard of these slits are 4 slits, 1 for each cylinder. One is larger than the others to provide a signature effect for number 1 cylinder. As the rotor plate turns, it passes between 2 sets of diodes positioned in line with the slits. The diodes above the rotor plate are light-emitting diodes, while the ones below are photosensitive diodes. When provided with a suitable voltage, light-emitting diodes transmit a fine beam of light. Photodiodes receive this light and use it to make a voltage output signal. When a slit is in alignment, the light beam passes through it and a signal is transmitted to the control unit. When the slit is out of alignment, the light beam is interrupted and the signal falls to 0. The control unit uses the 1 degree signals to gauge engine RPM and crank angle position in 1 degree increments. It uses the signals from the lower slits to gauge the piston position, with the signature slit identifying the number 1 piston. The signals from both sets of diodes are converted by a wave-forming circuit in the lower portion of the distributor body to on-off pulses to send to the control unit. After computing data from the various input sensors against the optimum settings for each operating condition recorded in its memory, the control unit determines ignition timing. It then switches the primary circuit on and off by controlling the operation of a power transistor mounted close to the ignition coil. The power transistor has its emitter connected to ground. The collector is connected to the coil negative terminal, and the base is connected to the control module. A voltage applied from the module sends a small current through the base emitter portion of the transistor to switch it on. Current can then flow from the ignition switch through the coil primary winding and the collector emitter to complete the primary circuit. Once the appropriate dwell period has elapsed, the module switches off the voltage applied to the base of the transistor, and the transistor switches off the primary circuit. The high-tension secondary voltage is then transmitted to the center of the rotor arm and to the appropriate cylinder. This cycle is repeated for each cylinder in turn.